So here's the section homework for 3.4, and we're going to start with exercise 15. And 15 gives us this function that says f of x equals x cubed plus 2x squared minus x minus 2. And it says to use the rational zero test to list all possible rational zeros and verify that they're on the graph. Okay. Well, the graph looks something like this. And this is in your book. This appears to be -2. This is -1. And this appears to be 1. Now, the rational zero test says that the following are possible zeros of any polynomial. Now, what the rational zero test will do is that the possible zeros are the positive and negative factors of your constant, which is 2, divided by the positive and negative factors of your leading coefficient, which in this case is 1. The only factors of 2 are 2 and -2, and the only factors of 1 are 1. And we also know that 1, I should say also, 1 is a factor of 2 as well. So there's 4 factors of 2. 2, -2, 1, -1. And when you include both plus and negative. So the only possible zeros of this are these. And as you can tell, the zeros are where it crosses the x-axis, and it crosses 3 times. So these 3 are your graphical zeros. And they are accounted for. There's one of them. There's another. Oops, I got 2 of them. And there's my third one. So all the possible zeros are located here on this graph. Now for 19, they don't give you a graph to work with. They say just find all the rational zeros. And for 19, they give you a function. They say f of x equals x cubed minus 6x squared plus 11x minus 6. So the way this works, we're going to have to list plus and minus all the factors of 6. So plus and minus 6, plus and minus 3, plus and minus 2, plus and minus 1. And they're all divided by the factors of your leading coefficient. Well, it's nice because they're all over 1, so we don't have to write another set. So I just have 8 possible rational zeros. And the way that we're going to check is I have to check to see which one, when using synthetic division, gives me a 0. Now this may seem like it'll take a long time, but if you do this, it doesn't take that long. That's not a 0, so 6 is out of the question. So now I'm going to test it with -6. You can already tell that this is going to start to get to be a very big number. Well, the 6's don't work. So let's try 3. Found my first 0. The first 0 is at 3. And the nice thing is that now that I found that 0 of 3, so I have my first 0 here. And the nice thing about this is that I can now take this polynomial, which is x squared minus 3x plus 2, and try to find the zeros for that and see where does this equal 0. Well, I can go through and test this, or I can ask myself, how can I solve this? I can use the quadratic formula if I want to, or I can see if it's factorable, which it is. I can factor this into x minus 2 and x minus 1. Okay, so there's my factored expression. So there's my other two zeros, where this is equal to 0, which is 2, where this is equal to 0, which is 1. So I have my 3 zeros. So it's at 3, 2, and 1 are my 3 zeros. Now I'm going to do another one with 25. So for 25, we have this following function. It's in different notation. It's c of x now, but that's the same thing, just a different letter. 2x cubed plus 3x squared minus 1. So what I need to do is I need to write out the factors of the constant. So that's just plus or minus 1 over plus or minus 1 or plus or minus 2, because I'm dealing with the factors of this. Well, now I have to deal with 4 different numbers. 1, negative 1, 1/2, negative 1/2. Now you can check these the same way we checked the ones before, but you have to be very careful because we're missing a placeholder. We're missing this x term here. So I got to deal with that like I dealt with before. So I'm going to put the 1 here. So I get 2, 3, 0, negative 1. Let's see what happens. Well, 1 didn't work. Let's try negative 1. Negative 1 seems to work. So negative 1 is one of my zeros. Now again, the same type of thing works for this. I have 2x squared plus 1x minus 1. I can check this with the same test. Oops. You can see I accidentally hit my YouTube link. I can use the exact same test, or I can just say, well, where is this equal to 0? Can I factor this? Let's find out. I'm looking for numbers that add to 1 but times to negative 2. That would be a positive 2 and a negative 1. So this has a negative 1 in common. This has a 2x. This has a 1 in common. This has an x. So this factors into 2x minus 1, x plus 1. Now this is weird because we get negative 1. And like I mentioned in the videos before, this doesn't take into account multiplicity or something getting repeated. So you might have to check something again. So this has a multiplicity of 2. So it's a 0 twice. And this one is a 0 of a half. There's my other one that's a possibility. So the zeros for this are -1 1/2. It's just that -1 appeared twice. Now we're going to look at 55. And 55 says the following. It says that we have this function x cubed minus x squared plus 4x minus 4, and we know that one of the zeros is 2i. The question is asking us to use this 0 to find all the other zeros. Well, if we know that this is a 0, that means that this is true. Okay? This has to be true because if we plug 2i in, we have to get 0. If 2i is a 0, then -2i is a 0. So therefore, x plus 2i has to also equal 0. Which means that if I multiply these two things together, if these are my two zeros, they have to give me 0. So now I have to use a matter of foiling, but I don't have to multiply the inside terms because they're going to cancel out since this is a plus and a minus. I get x squared minus 4i squared, which is equivalent to x squared plus 4. Now since these have two zeros, this is a factor of this. It's a factor of it. I can't use synthetic division for this though. I can't use that. So what I got to do is I got to use long division to divide this out to see what happens. Now again, you can't just put x squared plus 4. I have to take into account the 0x for a placeholder. I divide this in, I get x. I times this, I get x squared plus 0, or x cubed plus 0x squared plus 4x. I'm going to subtract all of this, and I get -x squared. These cancel out as well as these do. Carry down the 4, which is negative. Now I'm going to divide x squared into -x squared, which is a -1. And I times this all. I get -x squared minus 0x minus 4. Again, I could put the 0x there, but notice that there's no 0x there. We don't even need it. These cancel out. No remainder. We shouldn't get a remainder because it's a factor. So this is what's left. So the way I would write this is equivalent to x squared plus 4 times x minus 1. Okay, and if we're solving this equal to 0, we already know these two zeros. They're right there. Those are my two zeros for that. Now I just need to write the last two. Or not the last two, the last one. And that's this one, which is a 1. So my three zeros are plus or minus 2i and 1.